Hi OSLO users, in this video we're going to cover the wide angle mode out of OSLO's ray aiming modes. So the wide angle ray aiming mode traces reference rays for all rays through a system. Essentially it is going to start at the stop and trace them backwards until they go through the correct object point as expected. So all rays are aimed to fill the stop with maximum accuracy, and that includes spacing between rays to sample the stop. Consequently, this will work well for highly aberrated systems, systems with a large amount of pupil aberration, and also special apertures. It's a mode that's necessary for extremely wide-angle systems such as fisheye lenses. I'll show an example of a fisheye lens in this video in particular as well. Accuracy effectively is being gained in this mode, but it's at the expense of speed because we are tracing reference rays for all rays through the system. It must iteratively trace them. One point to make is vignetting factors shouldn't really be used with this mode because there's not much point to it. The OSLO is going to check for all the rays being traced through the system and is going to naturally block rays that aren't getting through the system, and therefore the idea of using vignetting factors to estimate the size of a stop for an off-axis location really is not necessary. The issue, of course, with this mode is you are gaining the accuracy at the expense of speed, and if you start trying to use vignetting factors, you may actually start causing some issues with the accuracy. We're going to look at 3 examples, but before we do that, we're going to just look at what the online help says. So this just talks about how and what this type of mode that's suitable for wide angles. What you do is you iteratively trace the rays backwards, as I said earlier. One thing that it points out here, and I'll show this in the fisheye lens, is you can actually specify a field of view of, say, 45 degrees and then define fractional coordinates that are much larger than that if you have systems with an extremely wide field of view. So this can even include systems that have a half field of view greater than 90 degrees, in other words, greater than 180 degree field of view, and I'll show that with the fisheye lens. The reason why it likes to do that OSLO does this is so that you can still do paraxial calculations and some things like that, which you need angles that are smaller to do that. Okay, so the first example I'm going to show is the double Gauss lens. I've gotten rid of the checking off the apertures because we don't really care about vignetting in this case. And here's the stop in the system. I'll make this a little bit bigger. You can see, of course, the rays aren't getting through. This is the central reference ray mode. Now, if we were to go to general here and change to the wide angle mode, what's going to happen is if we go and update this window, what will happen is you can see now the rays are correctly going through the edge, and the same thing will happen here. I need to actually make sure that we're at the stop surface. So they're at the stop. Now you can see the rays are spaced nicely in the pupil, and they're so sampling is very good, and then as well as it fills the entire pupil stop correctly. So we are launching at the stop in the system, and it is filling it correctly, which is what we're really doing with this. Of course, we've lost a little bit of speed. You can't see it in what I'm doing right now, but if you're doing something that's heavily ray trace intensive, then that speed differential might start being noticeable. Okay, so the next thing we want to do is we want to go to the demo triplet example, and I've modified it a little bit again here. If we look at the lens drawing conditions, I've gone ahead and I've drawn 31 rays on axis and off axis because in this particular case, and here we can also go to trace rays through the pupil this way, and you can see the aperture stop actually in this case is number 4. So let's go to number 4. You can see that going through the stop, we actually block a lot of the light. This is very expected for this system because it's vignetted. Now, in this particular case, we are also starting with the central reference ray. If we wanted to gain accuracy, we could switch to the wide angle mode, which would work perfectly fine. You can see it changes those rays just a little bit. But in practice, we may not need to use this mode for this type of case. but you could use this mode if you were going for, if you really wanted to maximize the accuracy. So see the other ray aiming options to see what you can do with it. So it does work perfectly well with vignetted systems, and in this particular case it will check all of the rays and see if they're blocked. So that iterative ray trace process does slow us down, but we do gain the accuracy. So the last system to show is an extreme wide angle system. So this is a fisheye lens. We can look at it bigger here, and you can see you have a field of view that's actually greater than 180 degrees full field of view here, because you can see the light's coming in actually at a greater than 90-degree half field of view. And we have all this negative power in the front that's working to bend that light correctly or effectively into the system, and then the stop is here buried in the middle. Now this type of system is impossible to model without a mode like the wide angle ray mode, so we must have it on here, and if we go, we see that it is indeed on in that location. There are some surface notes in this lens where it talks about the wide angle mode and how it's actually set up. If you look, it only has a 45-degree field of view defined, and that's for things like the praxial calculations of the lens. But in practice, to get these larger field angles, what it's been set up to do is it's got drawing, in the drawing conditions, you can see we have a 2.0, which is a 90-degree half field of view, and then a 2.4, which is even greater than that half field of view setup. So if you're optimizing or doing other things like that, you could certainly set up some field points that have greater than 1.0 fractional field coordinates, if you like, and you can also do other analysis by using fractional coordinates that are greater than 1.0. So you can set it up with this smaller field of view, but then in practice design it and analyze it at a greater field of view, and everything holds together. Now, of course, the key to this all is this required the wide angle mode, and the bottom line for the wide angle mode is that because we are tracing reference rays for all the rays, we're gaining accuracy. And so this is the mode that's the one where you're filling the stop as sort of accurately as possible, with the exception of a few special cases like the extended aperture mode or telecentric pupil, some entrance pupils, some few cases like that. So this is the mode to use when you really want the highest accuracy, as long as it's applicable in the case that you're analyzing.